This is a follow-up video to one where we had inscribed in a semicircle of radius 1, and we were asked to find the area that represented this rectangle. So we wanted to express the area of this inscribed rectangle as a function of theta. And I'll go ahead and link that video in the description in case you missed it. But this is what we did in that video. Using the diagram here, we have this distance is x. So this distance here is also x. Yes. And again, I'll link the video. And then the radius is 1 from this point. This is center point to the point of the circle. That's the radius. So this dimension here of this right triangle was also 1. So we found in that video that the area was 2 cosine theta, and that was actually this right here. This was cosine of theta, but then we went at the length here, so that was also x because of the symmetry and so forth. And then this side turned out to be sine of theta. So you can call this the length, and say this would be the width. So the area of the triangle would be length times the width. There we have it. Now in this video we want to find the angle. In the previous video we were to find the formula that defined this area for this particular rectangle. Here we want to find the angle that maximizes. So what does this angle have to be in order to have a maximum area for this rectangle? So here's what we want to find: the angle theta that results in the largest area A, and then find the dimensions of this largest rectangle. So go to the calculator. Or actually, let me do this first. We know that the area of a circle is pi times the square of the radius. Okay, now in this case we have a semicircle, so I want to find the area of the whole circle. The area would be pi, and the radius is 1. So 1 squared is still 1. So pi, or 3.14, would be the area of the entire circle. So the area of the semicircle, let me just write this a sub s, would be pi over 2, or pi divided by 2, which would be approximately 1.57. So we can't expect the area then of the rectangle contained in the semicircle to be larger than 1.57. So what I did is I graphed, go to y equal here, and here I have this function here for the area that I erased earlier, but it was 2 cosine x, sine x, or here I have the sine x first, it doesn't matter. And on the window, I expect the angle to be some angle less than 90, so I have it from x is to 0 to 90. And the maximum value of y, which would be the area, has to be less than 1.57. So I've got that range from 0 to 2. And I'm going to graph. So that's what the graph looks like on the function that I mentioned. A equal to 2 sine x times cosine x. So I want to hit second, and then on the calculate menu, click trace. So I'm accessing this menu right here, and I want maximum. So I enter 4, click 4, and now once a left bound, hit enter. Now it wants a right bound. So go past that high point. It's kind of like a parabola. Vertex here, and that's where the maximum value occurs. Hit enter. And then it wants a guess. We can skip that, just hit enter. And this tells me that the maximum occurs at x is equal to 44.999. Well, that's just 45. Let's call that 45. And the y value actually gives you the value of the area, which will be the maximum. If you have a curve that looks something like this, a parabola that opens downward, the maximum value will occur at that high point or vertex. So what we have here then, remember the area of the semicircle is 1.57, so we expect something less than that. And this tells me that it's going to be 1. So to enter this here then, find the angle theta that results in the largest area, A. So from the calculator we can say this is going to be 45 degrees. Now you want the maximum area, it's 1. It gives it to you right here. And that's, of course, square units. Now here for 2, it asks me for the dimension. Find the dimensions of the largest rectangle. And so remember that the length was twice the cosine of the angle we find here, which was 45 degrees. And the cosine of 45 degrees, that has an exact answer, is the square root of 2 over 2. So this cancels out. So the dimensions then would be the square root of 2 pi, and then the length was equal to the cosine, sine of the angle, which was 45 degrees. And the cosine, or the sine of 45 degrees, is the square root of 2 over 2. So the dimensions are square root of 2 pi the square root of 2 over 2. So those are the length and the width if you want. And we saw that the maximum area is y equal to 1 from this calculation here in the calculator. But notice if I multiply these out, length times the width, I get the square root of 2 times the square root of 2 is the square root of 4. This which is 2, and then that's divided by 2. We get 1. So we get the dimensions there, and we got the angle that gives me that maximum value, which of course is 1. Thanks for watching. We'll see you next time.